Hello students, in previous lecture we explained how can we calculate the number of atoms from a given mass of a substance. In this lecture we will talk about the different concepts of mole. Actually there are three related concepts of mole. There are three related concepts of mole. One is mass related concept of mole. Second is number of particles related concept of mole. And third one is the volume of gases at S.T.P related concept of mole. So let's talk about one by one. First concept is mass related concept of mole. Second one is number of particles related concept of mole. Third one is volume of gases related concept of mole. So there are three related concepts of mole. First one is mass related concept, second one is number of particles related concept, and third one is volume related concept of mole. We will discuss three concepts one by one. First of all, we will start the mass related concept of mole. Before starting the mass related concept of mole, we must understand there are four different mass related concepts of mole. One is gram atoms mole, second one is gram molecule mole, third one is gram formula mole, and fourth one is a gram ions mole. So there are four mass related concepts of mole: gram atoms, gram molecules, gram ions, and gram formula. In other words, you can say these are the four modern latest terms of mole, like gram atoms, gram molecules, gram ions, and gram formula. So there are four mass related concept of mole. First one is gram atoms, second is gram molecules, third one is gram formula, and fourth one is gram ions. So there are four mass related concept of mole. One is gram atom, second is gram molecules, third is gram formula, and fourth one is gram ions. So we will discuss their formulas and how can we calculate gram atoms if mass is given, how can we calculate the gram molecules if mass is given, how can we calculate the gram formula if mass is given, and how can we calculate the gram ions if mass is given. So in all four concepts, mass must be given in the question to find these modern terms of mole: gram atom, gram molecules, gram ions, and gram formula. So what are their formula? Let's talk about gram atom. How can we calculate the gram atoms? The given mass of substance over atomic mass. How can we calculate the gram molecules? The given mass of substance over molecular mass. And how can we calculate the gram formula? Given mass over formula over formula mass. And how can we calculate the gram ions? Given mass over ionic mass. So as you seen that in all four formulas, always given mass is written above and divided with the atomic mass, molecular mass, formula mass and ionic mass. So these are the specific concepts of mole. Gram atoms mole is applicable for elements, to find the moles of elements, and gram molecules mole is applicable to find the moles of substance. Specifically it should be molecular substance. And gram formula mole is applicable to calculate the mole of ionic compounds, or even we can say those compounds, those inorganic macromolecules which have empirical formula. So gram formula is also applicable for those compounds. Remember this one, like we have silicon dioxide. In silicon dioxide we also apply the gram formula mole, because silicon dioxide is inorganic macromolecules which have empirical formula. And gram ions mole is applicable for ionic species like hydrogen ions, sodium ions, sulfate ions and nitrate ions. So as you seen that there is common points in all these concept of four concepts of mole. We always written the given mass above and always divided with the atomic mass, molecular mass, formula mass and ionic mass. So these are the four mass related formulas to calculate the specific moles, like gram atoms, gram molecules, gram formula and gram ions. Now we will talk about the elements. This is applicable for elements, and like we have H oxygen, nitrogen, chlorine. And gram molecules is applicable for molecular substances, like we have H2O, we have H2O, we have C6H12O6. And ionic compounds, gram formula is applicable for ionic compound, just like we have sodium chloride, sodium bromide, are inorganic macromolecules which have empirical formula. Gram formula is also applicable for those compounds. And fourth one is ionic species. Let's take an example of ionic species. Suppose we have hydrogen ions, chloride ions, hydroxyl ions, sulfate ions. So which mass related concept of applicable is applicable? It's depend on the nature of the species. If the species is elemental, then we will apply the gram atoms. If species is consist of molecular nature substances, then we will apply the gram molecules. If the species consist of an ionic compounds, then we will apply the gram formula. And if the species consists of ionic species, then we will apply the gram ions on that species. So which concept of mole is applicable? It's totally depend on the nature of the matter. Either the nature of metal is elemental or substance or molecular substance or formula units or ionic species. So according to the nature of the matter, we will apply the concept of mole. So there are four mass related concepts of mole. In next we will discuss the number of particles related concept of mole. Before going to next concept, let me tell you one thing very clearly. In these four concepts, if mass is given of any nature of matter, how can we convert the mass into mole? So you always keep in mind this formula, because this is a sum of all these four formulas. You don't need to remember these four formulas. You need to remember just one formula, which is sum of which is sum of these four formulas, and that is mole is equal given mass over molar mass. So this formula explain this formula given mass over molar mass. This formula simply explain the four concepts of mole. So you don't need to remember these four formulas, you just keep in mind this formula: mass, given mass over molar mass is always equal to mole. Given mass over molar mass, always convert the mass into mole. Now we will move next. Next we will discuss the number of particles related concept of moles. So there is a fixed numbers which always justify or explain one mole, and that number is the biggest, counting number in science or in chemistry, and that biggest number, counting number, is 6.022 into 10 to the raised power 23. This number explain 1 mole of any matter. This number explain 1 mole quantity of any substance, any matter. So 6.022 into 10 to raise power 23 is the biggest counting number in science, which explain 1 mole of anything, 1 mole of anything. So in chemistry, let's specify these numbers. As you know that in the previous session we discussed 4 mass related concept of mole. Let's convert those 4 mass related concept into number of particles. Suppose we have gram atoms. In gram atoms we can calculate the number of atoms. Yes. In gram molecules we can calculate the number of molecules. In gram formula we can calculate the number of formula units, and in gram ions we can calculate the number of ions. Let's convert the mass into number of particles. From gram atoms we will discuss the number of atoms, from gram molecules we will discuss the number of molecules, and so on. Suppose we have 6.022 into 10 to the raised power 23 atoms. This number will explain 1 gram atoms. 1 gram atoms, which means 1 mole. If we have 6.022 in 10 to the raised power 23 molecules of any molecular substance, it will justify the 1 gram molecules, which is mole. And if we have 6.02 in 10 to the raised power 23 formula units of ionic compounds, it also explains the 1 gram molecules, 1 gram formula, which means 1 mole. And if we have 6.02 in 10 to the raised power 23 number of ions, it will explain 1 gram ions mole. So as you seen that here we discussed the 4 concept of number of particles. In the previous we discussed 4 mass related concept of mole. Now we explain the 4 particles nature concepts of mole. If number of particles is equal 6.022 into 10 to the raised power 23, whether they are atom, molecules, ions or formula units, this number always explain 1 mole of any substance. You can say 6.02 in 10 to the power 23 atoms, molecules or ions or formula units is always equal to 1 mole, 1 mole, 1 mole. If we want to convert, no, let's talk about their concluded points. If we simply want to calculate the mole from number of particles, as we discussed in previous session, how can we convert the mass into mole? In this we will convert the number of particles into mole. So you just keep remember this formula. It will help you to solve many problems and many MCQs. And what is the formula? If you want to convert the number of particles into mole, then you must divide the number of particles with Avogadro's number, which is 6.02 in 10 to the power 23. So you just keep this formula in your mind. If you want to calculate the moles from number of particles, then divide the given number of particles with Avogadro's number, which is fixed number, and you will get the moles. So always divide the given number of particles in the question with Avogadro's number. You will convert the number of particles into moles, or you will get the mole from number of particles. Now in next we will discuss the volume related concept of mole. And what is the volume related concept of mole? Keep in your mind one thing which is very important, and that is the volume related concept of mole. The volume related concept of mole. The volume related concept of mole is applicable only and only for gases at S.T.P. Volume related concept of mole is not applicable for liquids, solids or solutions. This volume related concept of mole is only applicable for gases at S.T.P. What is the volume related concept of mole? Let's discuss. If you have 22.414 decimeter cube or liter of any gas at S.T.P is always equal to 1 mole. Is always equal to 1 mole. 22.414 dm cube, decimeter cube or liter of any gas at S.T.P is equal to 1 mole. But point to be understand is this: okay, gas must be at S.T.P condition. Actually this concept explain the ideal gases. This concept is applicable for ideal gases. That's why we specify the condition at S.T.P. So 1 mole of any gas at S.T.P contain 1 mole. But if we have 2 mole of a gas, 2 mole of gas, then multiply this value, it will be 2 into 22.414 dm cube or liter. So as you seen that if we increase the mole from 1 mole of a gas into 2 mole of a gas, the volume will be double, 22.414 into 2, which should be 44.818 decimeter cube. It is very simple concept. Always remember that 22.414 dm cube of volume of a gas always contain 1 mole. Now again in the end we always discuss the concluded formula. How can we convert the volume into mole? In question, volume should be given, must be given in the question. And how can you convert the volume into mole? So formula is, you simply you simply divided the volume of a gas with 22.414 dm cube. Always remember this formula. This formula will help you to convert the volume of a gas into moles. You simply, volume of a gas is given in the question, simply divide the volume of a gas which is given in the question with 22.414 dm cube, and then you will get the moles. So simply, very simply, you can convert the volume of gases into mole by just dividing the volume of the gas with 22.414 liter RDM cube of a gas. So we discussed the three related concept of mole. First we discussed the mass related concept of mole. There are four mass related concept of mole: gram atoms, gram molecules, gram formula, and gram ions. And there is one formula which is sum of all these formula is always divide the given mass with molar mass to convert the mass into moles. In second concept we discuss the number of particles related concept of mole. How can you convert the number of particles into mole? Just dividing the number of particles with Avogadro's constant value and get the mole. And in third concept we discussed how can we convert the volume into mole. Just divide the volume of a gas by 22.414 dm cube, which is a molar volume of a gases at S.T.P, to get or find the moles. Now we will discuss all these three concepts into one formula. And how can we find these? It is very simple. In this lecture, you just keep in your mind these three formula, which is conclusion of this lecture. These three formula. And what are these three formulas? Number one is mole is equal given mass over molar mass. This is mass related concept of mole. Then we discuss number of particles by Avogadro's number. This is particles related concept of mole. And third mole concept is by dividing the volume of gas with 22.414 dm cube, and its value is 6.02 into 10 to the power 23. So you just keep in your mind these three formula. This is the whole concept of this topic. In this lecture you just keep in your mind these three formula. By the help of this formula, with the help of this formula, you can convert the mass into mole. With this formula you can convert the number of particles into mole, and with this formula you can convert the volume of a gases into mole. So in next lecture we will discuss different queries or different questions to solve the concepts of moles by using these three formulas. So just remember these three formulas for your exams, for your competition exam, or for your medical test.